Okay. Is my screen visible?
Yes, sir.
Yes.
Few things. Okay. Screen. So in the last class, we stopped, I think, somewhere we were discussing, right? 1G. In 1G, FDMA was used. Uh, in the last class, I think we completed with the types of networks, right? Types of networks. So there are three types of networks. One is CS network, PS network, then VoIP network. These three are different. So for this, we have seen landline example. Just a minute.
Screen sharing software.
Yeah, yeah. Our participants are bringing. Okay, sorry. Right. So VoIP network, and we have seen CS network example, a landline for wire, wired, and we also seen GSM in wireless. Right. So how CS mechanism works. Right. So here, simply I can say there is a circuit established from circuit establishes from calling party to called, right? Then once circuit is established, either data or voice follows the same path. And the drawback is it is bandwidth reserved. The bandwidth will be, it's like a particular circuit is reserved between two users. So no one can use that line. So now capacity of the capacity of this CS network, either in wide or wide, right? It depends on the how many channels or how many switches are available, how many wires runs between two cities. If it is wide, total wires capacity of the network depends on the wires between two cities. When it comes to wireless, number of channels available on the particular base station. Of course, GSM it is fixed. 8 channels will be there, or you can say 8 slots, or you can call as a channels. So only 8 people can simultaneously. So then PS network, we have seen wired example as a wired example, internet, where packets travel packet travels in a different directions. There is no particular path. There is no definite path. Packet can take any path. So there is no route reservation or bandwidth reservation, I can simply say. Okay. I can say there is no particular route from the calling to, or you can say here, sender receiver. When it comes to packet communication, we used to say sender and receiver. Okay. So then we have seen wireless example as a LTE or 5G. Right, when it comes to LTE and 5G, both are packet networks. Uh, both are packet networks, I can say. So packet, when it comes to packet communication, there will be a routers, gateways, even hub, routers, gateways, hubs involved. Okay. So definitely, routers, gateways job is to forward the packets depending on the IP address. Each each router or gateways checks the IP address of the packet. Based on that particular IP address, packet will be forwarded in the network. Okay. So same concept is used in LTE and 5G. Anyway, we will see this one by one. VoIP network. So VoIP network, when it comes to wide internet plus IMS network. Alone internet, right? Alone internet is not useful for the voice transmission. No voice transmission. Okay, because this internet is a delayed communication model. Delay communication model. Right, latency will be higher compared to the CS network. CS network, there will be no latency or delay. Once circuit established, right, instantly data will be, or either data or voice will be received by the called party, or you can say a receiver. So there is no delay because same path. But we have seen an example when it comes to packet communication or internet kind of communication. Packet takes different routes to reach the receiver. So if one particular packet is taken a longer route, definitely, right, it reachability will be depends on the number of routers gateways. It's reachable, that particular packet reachability depends on the number of routers and gateways in that particular path. So definitely, if one packet is missing or packet is taking longer time to reach the receiver, then entire packets should wait for the missing packet. So that's why it is not suitable for the voice. But right, IMS, IP multimedia subsystems came into the picture, and they built IP multimedia subsystems to transfer the voice in data networks. So this has brought so many codecs to convert voice to data, voice to data, and this data will be transmitted. Just a minute. Okay. So this we have seen in wire, right? When it comes to wireless, right? LTE plus IMS gives you the Vivo LTE. Similar concept. Here LTE is data network, not useful for the voice transmission. So when it is integrated with the IMS, right, then it is possible to transfer the voice using data. So this IMS, right, same IMS is used here and here in the wireless, just integrated. That IMS is a little complex, but as it is integrated with the LTE, right, and very cheap communication. So this we have seen in the last class. Okay, so those who joined for the first time, please go through the previous videos, okay, so that you can easily understand. Right. So in the same way, right, as I said, we need to go through the basics first to understand the our further 4G and 5G. So when it comes to our interest is wireless, so now we are shifting to wireless. There is a landline, then SS7. A lot of things are there in wide. Still hard topics. IMS through wide, SS7, right? Telecommunication. Still, it is a hard because in the background, right? Even though wireless, when it comes to the core network, this SS7 and IMS core network is still hot topics. But as we are into RAN side mostly, and we are into wireless and RAN side. Okay, so that's why we are shifting to wireless. So when it comes to wireless, especially mobile, when it comes to wireless, then there are several wireless communication, satellite communication, wireless sensor network communication. Several things are there, but we stick to the mobile communication. Okay. I hope you are able to follow me, right?
Yes.
Right. So we have 1G, then 2G, 3G, 4G, okay, and 5G. Right. Simple thing is that base station, we call it as a base station, acts as an access point, right? Access point, and many mobiles access the base station, right? So here it is only one base station can provide communications to hundreds of mobiles. Of course, if it is 1G, only one user. If it is 2G, more than one user. When it comes to 3G, 4G, 5G, you can say hundreds of users. So what is the underlying mechanism on what technology on what kind of mechanism these mobiles are able to access, right? I can say 100 mobiles, 100 UEs. How these 100 UEs are accessing the access point, or you can simply say base station. Okay. So there is a concept called multiple access. Multiple access techniques. So multiple mobiles or multiple devices are able to communicate with a single access point. For example, Wi-Fi is there. Wi-Fi also, same thing, right? This is my Wi-Fi connected 4 or 5 mobiles or Wi-Fi devices. Need not to be mobile, but any Wi-Fi device, it can be Wi-Fi. So here also there is some multiple access works. Okay, so you can say Wi-Fi 6 or Wi-Fi 7 here OFDMA is working. Whereas in 4G, 5G, OFDMA is a multiple access, right? And 1G analog technique FDMA was used. When it comes to 2G, we have two standards. One is GSM, another one is CDMA. CDMA services are shut down everywhere. But the fundamental concept, this CDMA fundamental concept is brought into 3G as a WCDMA, right? And core concept still there in the OFDMA, we will see. So further this GSM further,
So in 3G, edge also is there, right?
uh, uh, those are all works based on the WCDMA.
Yeah, okay.
Okay, multiple accesses, same. Okay, so like you can say 2G, 2G plus 3G, 3.5G, 3.75G, like that. But fundamental technique, multiple access is either you can say CDMA or WCDMA or OFDMA. Okay, that's my point. Say for example, 4G, OFDM, 4G advanced, OFDMA only still. Okay, got my point.
Yeah, yeah, got it, got it.
So GSM, but GSM is using FDMA plus TD. So why industry is moving from still right recently 6G is also announced logo and some specifications are building for the 6G. So why right industry is moving from 1G to 2G, 2G to 3G, 4G, 3G to 4G, 4G to 5G, and upcoming 6G. Why? Right, definitely I can say capacity. Capacity. 1G was not able to provide capacity as per the user demand. Right, move to 2G, little superior compared to 1G. Again, 2G was not sufficient. Then move to 3G, not sufficient. 4G, not sufficient. 5G. So till this 4G, right, only the aim is, of course, 1G, 2G aim is different. Only CS, voice calls, but the aim shifted from the 3G data, 3G, then 4G, completely data. Of course, voice is there, but the aim of this 1G, 2G, 3G is different. 1G is only meant for the voice and CS based. 2G,
But in 2G, PS4 also is there.
that's what I'm saying. 2.5G, it is a GPRS, right?
Uh,
So 2G is CS. And if I say 2.5G, right, then this is GPRS, right? So packet core is added, but the main aim was voice. Then they added GPRS. Then they released as a 2.5G, 2.5G, right? Then 3G, mainly for CS as well as PS. CS was there, but the technology, underlying technology is different. Okay, right, we will see why they gone for 3G, why they gone for 2G from 1G. Okay, definitely I can say one thing is superior capacity and security. Okay, because 1G was not secured that much. It is analog, right? If anyone want to capture the uh, call or capture the channel, they can easily tune to the analog and they can capture the communication. But when it comes to digital we know zeros and ones, right? We can play with the zeros and ones in 2G, 3G, 4G, right? And capacity, then security, right? What the main things as main things in 2G, 3G, 4G, 5G, and of course, when it comes to 5G and 6G, application, mainly application only. These are, of course, data rate will be there, but mainly application only, right? This going application oriented. Voice to data, voice to communication shifted to data. Now data to shifted to application oriented. Okay, so let me go through 1G actually. What was the drawback of 1G? So usually 1G, okay, FDMA was using. Okay. So in this case, frequency division multiple axis, which means one base station. If one frequency is assigned to this base station, so total government, right, assigned 25 megahertz. 25 megahertz assigned to this 1G services by the ITU. Then the channel bandwidth, right? Channel frequency. Let me go through what is the channel, what is the frequency. Okay. So frequency means, right? We discussed, I think, but Let me go through once again. Frequency, I can say FM. FM radio frequency, right? 98.5 megahertz. Or somewhere 105.4 or something is there. I don't remember exactly. So this is called a frequency. Okay. So this is high frequency. When it comes to FM frequency, then when it comes to cellular, 1G frequencies, right? Around 800 megahertz. 800 megahertz. 2G frequencies. 900 megahertz is there, right? In some countries, 800 megahertz. So this is a frequency. But where is the channel bandwidth? Channel, oh, this is the frequency when it comes to channel. Okay. Channel to transfer the voice or data. Voice or data. So simply channel bandwidth, I can say this is higher frequency minus lower frequency. Okay. So higher frequency minus lower frequency will give you a bandwidth. So simply I can say it is look like a road, right, where traffic flows here. So we say the road bandwidth may be 2 lines or 4 lines. Right, bandwidth of this road may be 2 lines or 4 lines. Okay. So if it is 4 lines, right, many vehicles, more vehicles can travel. If it is 2 lines, lesser. Even 1 line road will also be the smaller road. Okay, single line, we say single line road is also. Definitely, I can expect, right, very less vehicles or very less vehicles can travel through single line, little more, right, little more. If 6 line, then you can say there will be no traffic. So bandwidth is also defined like that. Higher the bandwidth, higher data, or simply higher bandwidth, higher bandwidth, higher data, higher data. Of course, there is a Shannon theory. We no need to go through that. I think capacity equals to bandwidth into some log 1 plus S by N. So this was the Shannon. So capacity, right, if I say directly proportional to bandwidth. Higher the bandwidth, higher data rate. Lower the bandwidth, lower the data. So this is Shannon formula. So simply I can say exactly this is higher frequency minus lower frequency. Okay, higher frequency minus lower frequency will be the bandwidth.
Sir, I have one doubt.
Hmm.
So
Tell me.
earlier already we have discussed regarding frequency,
Huh.
but still I have one doubt regarding that frequency, as you saying like higher bandwidth, higher data
Correct.
rate. Yeah,
This.
correct.
Hmm.
Yeah, so it is like we have to assign this coverage, or it is automatically
No,
according to
coverage
the
is different.
frequency.
See, coverage is different. Ah, see, coverage
But
again depends. Let me go. So,
mhm,
coverage always depends on two factors. Okay, one is power. Okay, so three things. One is based on the power, height of antenna, height of tower, you can say. Then
yes, yes.
frequency also. Okay, frequency also. Right.
Yeah, that is I'm asking. So frequency, it is like it is assigned for 4G. We can say like we are using
Hmm.
1800 or 2100.
So 1G,
So
if I say 1G coverage will be little longer in terms of
Yes.
kilometers. I can say 30 kilometers. Coverage will be more than 30 kilometers. Okay, because at 800 megahertz. So lower frequency. I'm talking lower frequency. Okay, lower frequency, higher distance. Okay, signal
So
travels higher distance. Okay, so 900 megahertz, which was used at GSM. Okay, so I may say 20 kilometers or 15 or 20 kilometers. Just example. Okay, so original factors depends on the height power. If you are giving hundreds of megawatts of power, right, signal can go up to 40, 50. Theoretically, it goes 100 kilometers. Okay. So then when
no,
it comes to, hmm,
no, actually, so my question is like it is depend on the frequency,
yes,
or we
100%
can
it,
say it is configuration also is therefore we have to configure like right, ET is there, electrical tilt.
that is electrical tilt. See, if you keep antenna, so this is my
Mm,
antenna. If you keep this little distance, it travel. If you tilt this antenna, it fall here only, right?
yes, yes.
That is a different. That is a mechanical kind of thing. Okay. Antenna orient, definitely coverage depends on the antenna orientation. No doubt at all. Okay.
Mm.
If you keep completely like this, it will radiate here only.
No, now it is coming like for electrical tilt, like cable is there. It is connected to the RF.
Correct.
So for this configuration is there also. So at RAN site, but for this protocol, I don't know. So that's why I'm asking. So
No.
it have to configure, do the configuration, or it is by default frequency it is taking.
See, when we talk about, forget about this tilt and all, frequency, coverage, frequency, coverage definitely depends on the uh, coverage definitely depends on the frequency. That's what I'm saying. No? Lower frequency travels higher distance. Higher frequency travels lower distance. So 2000 megahertz, 2100 megahertz LTE. So I can say few kilometers, right? 5 kilometers. Okay. For example, 5G, if I can say 2300. Not only 2300, right? It is people are even mmwave 50 50 gigahertz. So then definitely I can say this travels 1 kilometer, even not 1 kilometer also in terms of 500 meters. Okay, and where I can simply say power and antenna height is same. Power and antenna height same for all base stations. Okay, so definitely frequency will affect on the coverage. Now you got.
Yeah, fine. Thank you.
Okay, right. So here frequency is a bandwidth and frequency channel. These three are right. I can say. Okay. Now here, so frequency, right, like megahertz and gigahertz, I can say. Whereas a channel bandwidth is derived from the frequency, right? Higher frequency minus lower frequency. You can call it as channel bandwidth also. Okay. So just these are basic terminology, frequency. And sometimes we call this frequency as a carrier also. Okay, carrier frequency both are same. Sometimes we call band. Okay, so band, frequency, carrier, all are similar terms. Okay, because band is derived from frequency only, and also carrier is derived from frequency
So
only.
carrier
So neither you
aggregation
can
also is the same or it is different?
same. So
Okay.
band, frequency or carrier, depending on the concept, depending on the when I am explaining, depending on the concept, I may use band, I may use frequency, I may use carrier. Okay, just keep it in mind. Others, any
Yeah.
doubts? Right. So when it comes to, let me go through what exactly the 1G was used. So here, a complete 1G, it is a FDM. So 25 megahertz was assigned to the 1G services by the government, and you can see this is the frequency allocation. So you can see 894 and 869 and 849 to 824. So you can see the higher frequency minus lower frequency. 894 minus, you see, 894 to 869. How much bandwidth will be? 25 megahertz, right? Okay, so this is assigned to entire 1G services. Entire 1G services. Then, but right, as I was telling, human voice, right? Human voice will be around 4 kilohertz, okay, approximately 3 to 4 kilohertz. Definitely, to transmit this voice, this will be higher bandwidth, right? So what they have done, they have divided this entire frequency into sub channels, I can say. So this itself is a bandwidth assigned for the 1G services, but this is too much. If you constructed 100 lines road, definitely it is useless. Or 10 lines road, it is definitely useless, right? If you constructed 4 lines or 6 lines between two villages, definitely it will be a useless, right? So if you constructed 4 lines or 6 lines to connect two big cities or two states, that is okay. But two villages, to connect two villages, if you constructed a 4 line, 6 line, 6 line, it is a use. So now what they have done, so this was right, I can simply say, to transmit the longer distance. Okay. So this entire frequency was divided into channels. So this 25 megahertz was divided into 30 kilohertz of channels each. So simply I can say here total 832 channels we will get. Channels, 832 channels of each 30 kilohertz. Okay. So here my voice is at 4 kilohertz, but this 4 kilohertz I cannot directly transmit, so that I use this channel frequency to transmit, means 30 kilohertz. So this voice will be right transmitted onto the 30 kilohertz at 800 megahertz. Okay. So this will be our channel bandwidth, right? Then this will be the frequency. Little confusing, but just as we go on, you will be able to understand. Okay. So simply, if you heard a word of modulation, right? Somewhere, if you heard of modulation, so this is what modulation is happening. Means like your low frequency signal will be converted into high signal or high frequency signal for easy transmission. Easy transmission, not easy transmission, right? To transmit longer distance. Okay. So there is again theory to transmit this one, right? If we wanted to transmit this 4 kilohertz signal, at least we need 2 kilometers antenna. It is not at all possible to construct. So to reduce the antenna height, 2 kilometer antenna height, it is not possible. So that's why we are converting this to 30 kilohertz so that we can construct maybe 100-meter tower or 120-meter. Okay, so this is easy, right? We can easily construct 100 meters or 120. So that's why this modulation will help you. Clear? So here, when it comes to 1G, this divided into, you can see, right here they shown 3 kilohertz itself. Okay, but it is around 4 kilohertz, 3 to 4 kilohertz. If someone is talking little loudly, that can go up to 3 to 4 kilohertz. So these are the modulation techniques. You can see frequency modulation or frequency shift keying modulation to convert this voice signal into the carrier, which can transmit it from mobile or base station. Clear? Hello?
Yeah, clear.
Right. So here government has assigned 25 megahertz to the 1G services, but this is a huge bandwidth. Only 30 kilohertz of channel bandwidth is required, so that we divided this entire 25 megahertz with the 30 kilohertz. We will get the 832 channels. So eight out of this 832 channels, right? For example, if I can assign one channel here from 832 channels, right? If I assign one channel here, okay. In FDMA, what happens? Okay, only one user can connect. One channel, one user. That was the drawback of one. So here, one user per one channel. Okay, of course, at that time, 90s or 80s, 1G, right? 80s, 90s. It was a great technology. It was a great technology, but for example, in this particular area, 10 users are there. So 10 users have taken the connection. 10 users are taken connection, but only one can connect it at a time. If second user wanted to connect, he will get the this. For example, if this fellow, right, wanted to communicate 24 hours, he connected and is continuously transmitting or continuously talking on phone for 24 hours. Others will get the busy. That was the problem. So generally, so if I say, okay, so this 25 megahertz frequency was divided into each channel of 30 kilohertz, 30 kilohertz. So we will get 1, 2, 3, 4, 832 number, 832 channels, right? And each channel will be assigned to one user, user 1, user 2, user 2, user 3, user 4. So here, one channel, one user. Definitely, I can say it was a great technology, but not capacity is not high. Clear?
Yes, sir.
Hello? So total frequency means like frequency divided, right? frequency division multiple access. My frequency, right, at 800 megahertz got divided into sub channels, divided into smaller channels, which is of each 30 uh, kilohertz, 30 kilo as assigned to each user. So if I take, this is time axis and this is frequency axis. So time axis, if 24 hours we have, right, in time axis. If this user one wanted to communicate 24 hours, then this channel will be in use for 24 hours. No one can use this. Okay. So means in a particular city like New York, 832 base stations were installed. 832 base stations were installed, and each base station, right, assigned with one channel. So this is first channel assigned, another base station installed, second channel assigned, third channel assigned. Okay. So at a time, how many people can communicate in entire city? Entire city, New York, for example, because the 1G was there. In entire city, at a time, only 832 people can communicate, not more than 832, because 832 channels. Definitely, I can say not efficient. At that time, thousands of people have taken connections, but only 832. Got my point? Hello?
Yes. Yes, sir.
Right. So, right, definitely I can say not a efficient technology or not a high capacity system. Right. Then people thought, because frequency is costly, right? 5G, in 5G auction, almost Airtel purchase, Jio, Airtel and Adani group purchased frequency, right? So total, they purchased channels at 1 lakh crores. I think one Indian government has got 1 lakh crores on this spectrum auction. You can see definitely the frequency or channels very costly. So then we should use effective. Then instead of FDMA, right, North American people, they brought TDMA. Okay. So FDMA splitted into frequency. Then these people thought, let's try to assign time-based channel allocation. One should not assign for 24 hours. Give some duration of slot so that we can cover more and more people. So they brought North American TDMA. So which means, okay, for example, this is my frequency. This is my frequency. What they have done, they sliced the frequency into a slots. Slot 0, 1, 2, 3, 4, 5, 6, 7, and right, 7 till 7 slots, which means in FDMA one frequency, one user, but here this slot is given to, right, user 1, user 2, user 3, user 4, user 8 on same frequency. Now we are able to allocate channels to 8 people, which means, right, so one frequency, you can say frequency 1 or channel. Okay, so one channel is assigned here on this base station. Okay, so now same frequencies, means channel is only one channel. Now 8 people can come in. Definitely little superior or little high capacity compared to FDMA. Correct or not? On a single channel, 8 people can simultaneously communicate. Definitely, it is capacity increased from 1G, right? Correct or not?
Yes.
Okay. So then, North American TDMA, then in Japan, there was a PDC communication. Different countries have developed their own. Japan was having their own telecom network. Still, they have different, they follow different. So 3GPP is a standard. If somebody wanted to build their own network, that is up to them. But when they are releasing to the world market or others, definitely they must follow some standard. So then, uh, during this Europe, they developed GSM. What they have done, exactly GSM. So in 1G, we assigned channels in terms of frequency. In N8, of course, this is almost similar. 1G plus, we can say North American TDMA. Here we are assigning time based. Either we are assigning frequency or time. Then GSM, right, brought. Why can't we assign both TDMA plus FDDMA? Which means a kind of check boxes. Users will get the check boxes kind of thing. So this is the frequency. This is the time. Right. For example, this is my channel. Okay. This is another channel. So here it is. Frequency. This is time domain. So this is one channel, first channel, second channel. We will see more tomorrow on this third channel. Right? They divided time also. Okay. So for example, this is assigned to user 1, user 2, user 3, user 4, user 5, and so on. Right? For some amount of time. Next time, there is a possibility that frequency can be changed. Right? Frequency can be changed. Here, maybe this may be assigned to, this box may be assigned to user 1, user 2, user 3, like this. So this is called generally hopping. Okay, that we will see. It's like uh, if somebody wanted to capture the communication, right, for some amount of time, right, users will have this frequency, jump to this frequency, somewhere jump to this frequency, somewhere jump to this frequency. So there is a frequency hopping concept, right, which will provide higher security compared to 1G services. We will see how this was designed. Okay. So when it comes to this slot duration, very smaller slot duration is very smaller here. Means 577 microseconds, right? Smaller amount of time is given to user 1, user 2, user 3. Like, and this cycle will be repeated. Repeated transmissions will happen. Okay. This we call actually the frame. So the smaller part is called the slot. Combination of 8 slots we call as a frame. So data in terms of frames. Okay. For now, I am closing. We'll see tomorrow. Okay. No doubts, right?
No doubt, sir.
Okay.
Yeah.
Okay. Huh. Okay. Right. We'll see tomorrow. On Monday. Tomorrow there will be no class. Hello. You have any doubt?
No,
I,
no.
No, no,
I
sir.
given you I given you basic classes access. Still, basic classes are running. Don't worry. Right? Maybe it takes 3 more days to start the 4G. Okay. Right.
Okay, all right.